Welcome back to another Basics GameMaker Studio tutorial, and today we're going to discuss in detail a few things, how the new, in quotations, collision system is actually working, and the upsides and the downsides, and some twitching and some hyper speedo action, which is kind of hilarious, but we have to clamp that down also. There are a few issues with that thing, but of course it is great. It does unify a few things, but sadly I cannot give you a one size fits all solution. I can give you a rough sketch how that could work, and for most games that would be good enough. And for example, if you just say like, I don't really care about slopes, then this should be actually pretty sweet for you, because this system enables you regular jump and double jump if you like, and then just basic collision on instances. But of course, once again, a few issues, and then in the second part, I'm sorry, this video will be definitely very long. We will just go through what all these things mean, but of course you can tweak them to your liking, and then at some point maybe you get the result which you're looking for. So therefore, sorry once again, this will be a long video. No easy solution here, but of course once you have to set it up, you can just fire off and forget all of that what we just discussed. So this is pretty cool. Alrighty, so if you want to join me on this small little journey of hyperspeedo and more, then stick around. This is One Up Indie. I am a developer, so if you like what you're seeing and hearing, then why not consider sharing, liking and subscribing to the channel, of course. Alrighty, so a few little things before we start. There is a new function which is called, and this is based on that, Mr. Move and Collide, and this is tons of issues which you're having later on, but this is just for platformers, for top-down games. This is working flawless with the default setup. Really cool. We'll make a video on that too, but this is for the platformer, which is a little bit more intricate. Definitely a few more things which you need to take into consideration, but let's go into our drawing board and check out what do I mean by that. So let's say you got this dude here, right? And then we are just placing some instance walls, because it's based on instances, and you just got your walls everywhere. And then with the dude, you don't want to bump into that, and then you want to have jumping powers and a force which is pulling you downwards again. And of course here you don't want to clip into the ceiling, you just go up and down. So basically what a platformer with gravity is doing. Easy peasy stuff. And then what Move and Collide is doing, it's taking the current position of yourself, and this is very important to understand. So it's basically taking like, hey, your position on your X and Y scale. So this is, for example, your anchoring point, which is normally the bottom center, but of course you can put it in the middle center of your sprite. This is up to you. And then it's just saying like, hey, what kind of speed are you having for one step? So let's say it would be like a huge thing. And then let's say this is 8 pixels or 10 pixels. This is quite a lot for these games. Normally it's just 2 pixels or 1. It's just definitely less. And then it's having in between steps or iterations, so to say. Then let's say the default one is 4. So it's doing this. It's like slicing up the whole speed into kind of different steps. And then it's moving here, and it's just checking, hey, I'm moving. Is there a collision here? Nope. Awesome. Then next iteration, I'm moving here. Is there a collision? Nope. Sweet. Then I can move. And then at some point, it's going through the whole cycle. And then if there are no collisions in between your walk speed horizontally and of course vertically later on, then you can basically freely move. And if not, it has in between values, and therefore we have some hilarious clipping stuff later on. But you will see what I mean by that. So this is how the whole thing works. Takes your current position, then kind of sets like, hey, this is my goal speed, and this is where it should be ended. And in between, we see, hey, is there a collision? If not, move there. And then, of course, if you have there are some, let's say, counter forces which you can define. And this is how, for example, slopes work. You just push the dude, like, you just clip him upwards. So this is how basically all that stuff works. So how does that look under the hood? So here we just kill that. First of all, we need kind of our setup to be how that works. So you got your invisible or not invisible instances. This is of course up to you. And then these are walls, and of course some of the walls are slopes, so we can actually deactivate our tile sets. This is how it looks under the hood. This is actually the level on which we are bouncing off, and this is defining where collisions are happening. And normally, if you, for example, have a wall, then I don't know, it's just a sprite, and then it has the regular automatic because it's just a rectangle, easy peasy. But if you want to have slopes, which is a little bit more advanced, then you need to give your sprites a different collision mask, which is of course slower, but you need to have this kind of triangle thing. So therefore you go from automatic to manual, and then you set it to precise, and then you got a precise collision on the things where you have like your pixels on. So this is how that works, and then we just face plant well, everything on our game. That's basically how that works. That's the whole theory behind it. And now we got our player, and he tries to move and navigate, and then he's just checking like, hey, am I having collision on the left, on the right, so horizontally, or for example am I having a collision upwards, so as a ceiling, or the ground below you. This is how the whole theory and practice work. So let's actually set the whole thing up. Not too much to see here because there are not too many values. It's actually pretty straightforward and pretty easy. So the first thing which we need is, and this is optional, a walk speed. So how fast you want to go horizontally, so to the left and to the right. That's it. And here we go to hyper speedo issues in a few seconds. So the first thing which we have to do is get inputs from our keyboard or our controller and so on. But just imagine you have inputs. Your keyboard, you press to the left, you press to the right, or maybe space for jumping. Easy peasy stuff. Hopefully I don't have to explain that again, because that should be more than, well, and this is just an old hat. If not, link in the description below for how inputs work. And then we check constantly for a left input or for a right input, because we're just pressing the key, and for, well, jumping, we just release the key once, and then we just use it once to reset something. So how is horizontal movement actually working, which is the easier part? So let's say we just say like, hey, we store into one variable your input from left to right, because they are kind of on one scale, so to say. So we just say right minus left, and then we can have values which can be -1, 0, 1, because here these dudes just can be 0 or 1, and then therefore this is the end result, and then times your walk speed, which we set for 2. And for now, nothing is happening. Now we need to use and abuse the new move and collision function, which is doing a lot for us. It's actually moving our dude. So let's say move and collide. And here we need 2 input values, and then the thing which we are bouncing off. And once again, we are inputting a value of future prediction where to go to. Very important to understand. So this value, so the x value, is your speed in, let's say, horizontally, where you want to go. And then move and collide is deciding like, hey, is there a collision? If not, all good. But if there is one, oh, whoa, whoa, no way, you cannot go there. So this is basically just blocking you from going there. So it's taking your current position. And once again, our dude has its anchor point. Let me actually check out here at the very bottom, and it will just use this one, and of course the collision mask, which is that. But I guess I have a different collision mask setup for here, but of course it's basically the same thing. It's just a box, so it looks nicer. But of course I will show that later on, because I can debug. And then the second input is, let's go with 0. For now we are not putting any inputs, and therefore there is no vertical or downwards or upwards movement. So 0. And then what do we want to bounce off? Our walls. So basically all of them here. Once again, this is a parent object, and having all the children, which are slopes and not slopes, just regular rectangles combined, and then we just check like, hey, for collision. This is working already pretty cool. So actually let's check this out. And then, for example, we're pressing left and right, and the dude is moonwalking to the left and the right, and then he cannot go anywhere. As you can see, working pretty fine. Therefore, that's what I said, working pretty sweet for top-down games where you don't have well, counter forces and up and down forces and so on. Here this is working extremely efficient, which is great. So this is what we want to have. And let's make this a little bit more beautiful, because that looks like, yeah, much better. Then deactivate, yeah, let's deactivate it, so it's actually looking much nicer. Much nicer. All right, and now we need the second part, which is the vertical speed, which is going up and down. So basically you have one force, which is your gravity, which is pulling you down. You could actually use this one, but I had some issues with clipping and so on, so we're not gonna use the internal one. So basically you have a constant pull value, which is pulling you downwards. So let's implement that into the step event of our player. So here, once again, this is just applying all the stuff which we do beforehand. And we just say like, hey, pull the dude down. But of course, for now, this would be just a pulling down force, and then nothing is happening. So for example, we could actually say like, hey, we have a gravity force pulling downwards. But as you can see, hopefully right now, it's not a good solution. So here we have a total value of VSP. So this is the vertical speed, so the downward speed. This speed value is kind of the combination of those two, which I'm going to discuss in a few seconds later on. And this value would be going, would be becoming pretty big. As you can see at the beginning, it's really small. So gravity, I don't know, what is it, 0.2. But after a few seconds, it will be like a number like 15, 20, at some point 1000. And that would be not the best idea to do so. So how can we, well, clamp this value? Well, we reduce the value to small values. So let's say we just say like, hey, clamp is just, you know, clamping a number. So our v speed to -5, which would be the maximum upward speed, and 5 the downward speed. And therefore we are just checking in advance, once again, from our current y position to this projection point, and then it would be always just 5, which is good. So basically this could work. And then now we have a gravity force. So let's put this dude here, and then hopefully this is already working, and he already fell down. This is good. And then we can hyper speedo. And this is the bad part. And if you're thinking, what the hell is going on? Are we enabled? Did we enable hyper speedo for some specific reason? Now, this is kind of the weird thing about this whole setup of moving collide, and it's just taking your downward speed and then just adding it kind of to your horizontal speed, and he's just like skating like crazy. So we need to counterbalance that. And here, if you see the tooltip, there are a few more values. So once again, to bounce off, your projection vertical speed, your projected horizontal speed, where to go to. Now, comma, then number of iterations, this is set to 4. If you, for example, remember what I did say before, so how many times do you want to have and check? You can set this from 1 to 10. Of course, the more iterations you're having, the more granular it becomes. But of course, it's sometimes counterproductive in that kind of regard also. So here, this is set as a default value as 4. So it's actually set here, number of iterations, just a blah, 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 blah. And then it's just giving you well, a calculation. Basically, it's just checking like, hey, how many times do I want to check and move and check for the projected end result of movement in well, horizontal or vertical. That's pretty much it. Then we got more of those shenanigans. Well, let's actually go into that, what they do mean. So the next one is xoff and yoff. These things are set as 0 per default. They just mean if you are, let's go back to the drawing. So let's say you are here. So if we're clipping, what's happening? Do you want to push this guy a little bit off? It's 0, you will just be strictly being on the line, which is good. But for example, if you just go with 1, it will push you up, which is good. But of course, let's say you are here. Oh, I didn't count, I didn't draw that in. So let's say you have this beautiful little slope here, so and this is how basically the slope is actually working. So let's make this beautiful art. Lovely. So for example, if you're here, and then you would say, okay, it's not a direct wall, and then this thing would push you up a little bit all the time, and this is what the two numbers are good for. So these numbers here could push you upwards or downwards. So basically here you could, I don't know, always go with -1 or -2, and then you will have and start to having some jittering, but this is for the advanced part. Then of course, to avoid hyper speedo, you would just say like, hey, what is actually your maximum horizontal speed? So we just take the movement speed which we're having set up here, and then for your maximum y speed, I don't know, 0 as default, or let's say 5, which by the way we clamped it anyway here, so this should be working. So let's try this out if we solved our issue with hyper speedo, and as you can see, working again pretty good, and we are falling down and we cannot go anywhere. And now we come to the last part, which is kind of easy, how to implement a jump. Because what is a jump? A jump is actually kind of easy. So we got our dude here and we are sitting here, and here we want to go upwards. And for now, we just have a force which is pulling the dude all the time downwards. So for that, we just set our upwards and one time an upwards force. So just a and then at some point the downwards force is just making the number and going it and pushing it all into a downwards. So basically putting the player into a downwards position. That's what it's doing. So basically downwards force, and you just apply upwards once. So two forces. So how does that look like in code? Kind of easy. So once again, we set our gravity as the constant thing updated and pushing and adding it to the result value. So basically what it's basically doing, so we got our gravity pushing and having the v speed, so the vertical speed downwards, and here we just apply the jump force, which is upwards, and upwards means it needs to be minus, because plus values go down and minus values go up. So how can we implement that into the whole thing? Well, we just say like, hey, if we press our jump button, what do we do then? Well, we just set our v speed, which is constantly being pushed down, but of course clamped to a maximum value of 5. We just say like, hey, let's go. I don't know, what did I do here? We just used then our jump force, which is -5. So here we go. And of course here it's just clamped, so we cannot go over that. And let's actually check out what's going on, because now we got infinite jumping. And so basically we got double jump. So we just walking, and as you can see, we already have our platformer set up. Of course we got some twitching, which is kind of funny. So let's see, you are here and you can still go over there, even though it's not supposed to be. So this is one of the different things of shenanigans which you're having with this system. But of course, hey, it's not too terrible. But of course, if you're just here, we cannot go. But if, for example, if you go here, we can actually, you know, slide down, which would be for most people good enough. So here, downward sloped will work pretty fine. And as you can see, we got our infinite jump if we like, gravity, collisions, everything is working pretty fine. And then you don't even get stuck or something. So if you just wanted to have that, that would be good enough. But let's say you say like, I just want to have one jump and not the infinity jumping mechanics here. Then we need to do one thing, which is, well, not the most optimal way in my opinion, but it does work. So we just have a check. Let's get rid of that because that didn't work for some specific reason. We're just checking, hey, are we on the ground? So we're just having an additional collision. Yes, I'm sorry for that. I thought that would alleviate it, but it's not, as it seems. Maybe I'm just thinking in a wrong aspect, but hey, it doesn't seem to be. So we're just checking for a collision point. So what are we doing? We're just having an additional, all the time, a check, hey, above us, below us. So for example, come on. So here we're making, no, this color is terrible for that. Come on. So here, this is our X and Y point, and then a little bit below we're just checking, hey, is there ground? So +1, let's say, or our fall speed, which is then I guess a little bit more accurate. Do we have something below us? If not, we are not on the ground. So it's just a variable just checking, are we on the ground? Yes, no, yes, no, yes, no. And then most of the time when we are jumping, we are not on the ground, and then we are on the ground, it's saying like, hey, we are. So how does that look like in code? Well, kind of easy. If you have a collision point, then as you can see, y plus our v speed, so basically the thing which is our downwards pull value. So if there is an object wall below us, then it's just saying like, hey, are we jumping? Are we pressing our jump point? And we are not, no one. So what does that mean? So let's say you have a collision point. Two things can happen as a return value, which are stored in this variable. One is no one, so basically nothing is below us, which is good. But if there's something below us, so a wall or a slope or something like this, we are kind of on the ground. So basically we are just idle on something. We are just sitting, standing on something. And therefore we just say like, hey, no, we are not in the air, so we are not no one. Then we jump. That's it. This is how it works. And let's actually check this out. Let's walk and do. And then, for example, I'm pressing in the air, no, double, triple, whatever jump is available. And of course, if you want to have double jump, then you kind of have a variable, and then each time you are on the ground, you reset the variable. But of course, not too important in my opinion. You can import it later. Should we do it right now? How long is the video? 20 minutes. Yeah, this is long. All right. So this is the easy way how to do collisions. Sorry for the long rambling, but this is how the whole thing works. But let's go actually into detail. This is the advanced part. If you just wanted to have a quick solution, code in the description below, you can just copy paste it like this, boom, you can use it for the game. Easy peasy stuff. But let's actually go into some more details, because here those values, once again, let's go over them so you understand what's actually going on. So the first two input values here, projection values. So what kind of point from your X and Y position, the anchor point, with your speed plus your speed value. So for example, you just input, I don't know, a number which is 8, 15, or V speed or whatever you want to call that. This is just a value on the projection. Hey, I want to go there. Can I go there? And then the question is of whom to check. And then of course you can have a little bit more elaborate stuff, which is just getting the instances on which you are colliding with. So you can actually do more with that. It's just not colliding. You're actually getting the instances back in an array. Yes, in an array. And then, for example, you could do Super Mario stuff and say like, hey, if an enemy is below you, destroy it. So you could actually do that for these kind of things. But hey, let's keep that to that. And then a number of iterations. And this is once again the point where I just said like, hey, how many steps of in how many slices do we want to divide your projection value where you want to go, which is between 1 and 10. For example, if you put this in a very low number, so let's say we actually do that with 1, then we have the issue. So let's say we just go with 1. You can get actually stuck here. So let's check this out. Yep, and I'm stuck. I can jump, I can do the air moves, but I'm stuck. And as you can see, what is this? We are floating. So this is not good. So therefore, make this value a little bit higher. So here, this is important to understand on this point. Then the next thing is the xoff and yoff. This is just basically pushing you off. And then it's just giving you perpendicular direction, which is like super fancy words for just, horizontal left, right, or vertical up, down. So you can say perpendicular and you're feeling like fancy and mathematical. You can just go, this is left or right. That's it. So, so for example, you can just say perpendicular movement of a flower, which is going upwards. So, well, if you want to feel fancy, use this word. Yeah. This is of course set to 0. But of course, if you want to do a little bit of pushing up, then what I just said, like, hey, let's actually, so let's, how many iterations? Let's go for, I don't know, 5. or 4, it doesn't really matter. And let's push the dude 1 pixel upwards. And this is what we actually get. And this is how the slopes work. So we just, are we stuck? Yeah, we're stuck. -1, my bad. So basically you just want to go and push it upwards. Yeah, we are working right now. But now, what is this? Why is this jittering? He's just like doing some moonwalking, some jittering, but as you can see, he can move the slope upwards. I haven't found a good fix for that, so here, sorry for that, but it does work. Of course, just here, you actually, can move the slopes up and downwards. Not sure how to fix it. Maybe in the future I will have a thing, or for example, if one of you guys has a good idea, please write me in the comments. That is very important for me to understand why this is doing some jittering and some stuff. Not so cool in my opinion, but of course now you can just walk those slopes up and down. This is this thing. And what else do we got? And of course we got move X. These are just basically maximum values. This is why hyper speedo is being clamped down to, I don't know, to as your walk speed, because it's kind of doing some computations, then it's just accelerating it for it's definitely not no reason, but it's just I'm not getting it why it's doing so, but I guess it's actually it's actually explained here, but I'm not sure what the mathematical equation is behind it. And this is the whole thing. Once again, super powerful. You can once again have some collisions with that, and then you can do actually more shenanigans with it. This is very, very powerful. So don't misunderstand that I don't like it. It's not doing it out of the box right now. Maybe in the future, maybe there will be some additional stuff, because let's say I tried it with the internal gravity. It just was clipping through it. I wasn't like, oh, am I doing something wrong here? It wasn't working, so therefore I had to use, in quotations, my own V speed and upwards and downwards forces. So here, if you have a better solution than me, please in the description below give me your comments or give me a link to somebody who does it, because as far as I remember, I checked it out, I would be the first to do this. Yay, first, but not the best as it seems, but for beginner stuff, good enough. So once again, looking pretty cool. I love the function. It does a lot. Move and collide for the win. So this is a very cool stuff, but still something is missing. I'm just missing something. I don't know what it is, but once again, maybe you guys know more than me or have a great idea and still like, and then of course I would correct it or make a second video on the move and collide for platformers. All right, that was it from my side. Long rambly video, sorry for that, but this is the way it goes. Hopefully you can use and abuse it. I will make an engine with this system, so the move and collide, and that could be very cool for, I don't know, pushing and pulling things, not just with regular colliding. So here, tons of potential I do see from my side. Alrighty, 30 minutes. Wow, way too long. Have a good one. One up indie.